In this video we're going to learn about hash tables. Let's start by talking about what hashing actually is. In computing, it's a process to uniquely identify a specific object from a group of similar objects. So for example, you've got your Scottish candidate numbers here. This is a unique object compared to this one. You think about it as like a similar idea to the database primary keys. Now the benefit of hashing is that it improves the efficiency of searches by removing a number of items from your potential search. Now a hash table is made up of two parts. The first part is an array containing the data, and the second part is a mapping function. This is also sometimes called a hash function. So let's talk about how this mapping function actually works. As I said, it's also called a hash function. It takes in some value, it performs a calculation on that value, and it returns a hash value. Usually this hash value is the array index that is going to be used to store the input value. So if we take an input such as spike and we pass it into the hash function, a calculation is performed, and then the hash value that's returned from it would be, in this case, the array index 7. Now there's lots of different ways of making mapping functions or hash functions, but here's one example. So we create a function called hash with an input as a string. It's going to return an integer, and that's our hash value. We loop, in this case, through every single one of the letters in the input string, and we get the ASCII value of each individual character and add it together. So we get the sum of the ASCII values of the input string. And when we're finished the loop, we will have a total. We then divide that total by 12 and get the remainder, and the remainder is returned to the calling function, and that will be the index that we are using to store our data value in. It's sometimes nice to visualize this as a trace table. So if we look at the algorithm from the previous page, here we go, and we use an example ABC as our input string. Let's go through it. So we're setting index to 0, and then we're checking to see if it's reached that len input. It hasn't. So we will add to output the ASCII value of A, which is 65. The index becomes 1, and then we add the ASCII value of B, so it's 65 plus 66, and that's 131. We change index to 2, and then it becomes 198 because it's 67 plus 131. And then index becomes 3, and that's the length of the input. So when it becomes true, it drops out. Output is the remainder of 198 divided by 12, and that's 6. And so the value 6 is our index, and it's returned to the calling function. Now the hash function is one important part of hashing. The second thing is the add procedure. This is what is used to add the data item to the list. So in this case, we start off by getting the hash value, okay, and then we use that index to add the input string to the array. But what happens if the last element already has a data item? You end up with something called a collision, and this is bad because this could mean that additional data is overwritten. There is a solution. There's a number of solutions, but the easiest one, and the one you should use, is to rewrite the procedure in order to solve the problem. And so what we're going to do on the next slide is we're going to look at this add procedure, and we're going to give it a little bit extra to try and avoid these collisions. So starting off with the first few lines of the previous add procedure, we are going to initiate a while loop. And this while loop looks at the index position and checks to see if it's empty. If it isn't empty, it increases index by 1, and it will continue until it goes all the way through the array and finds a gap. Once it's done that, it puts the input string at that new index position. It's just one possible solution. It's not perfect because then you have problems with finding that value later on, but it is a quick solution to a problem of overwriting data, and it does remove the risk of collisions.